Hi, welcome to solveandgo.com. This is the next video in a series of videos giving the solutions to the final exam for Math 135 from 2010. Okay, in this video we're going to see question number 12, which is a related rates problem. So what we have, I'm not going to write it all out, but I'll draw it and say it. We have a ladder, so this is a wall here, a ladder resting against a wall. Okay, so this is the ladder. The ladder is 5 feet in length. Draw that in here. Okay. So we have a 5-foot ladder leaning against a vertical wall. The bottom of the ladder is sliding away from the bottom of the wall at 3 feet per second. So this distance is, the base of the ladder here is moving away at 3 feet per second. And then we're asked how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 3 feet from the wall. Okay, so that's the question. Alright, let's set some things up here. First, give some variables some names. So we're going to call the height y at time t. Okay. And then this distance here, the natural thing to call it is x at time t. So what we're given is that, the ladder's x is changing by 3 feet per second. So we know x prime, let me write this in black. We know, let's make a list here of the things we know. We know x prime of t is 3. And the question's asking for d, so y prime, essentially, when x of t is 3. Okay, when the x also happens to be 3 feet from the wall. And we know x squared plus y squared is 5 squared by Pythagorean's theorem. So I'm going to erase the question. So what are we looking for? So we need y prime at this time here. Okay, so we need y prime at t. Okay, so with these related rates problems, you often the thing relating the rates is some sort of geometric equation. In this case, it's going to be Pythagorean's theorem. All right, so what we get, differentiating this equation here, we get 2x times x prime plus 2y times y prime. So this is implicit differentiation, really, with the chain rule, equals, excuse me, the derivative of 25 is 0. So we get 2 times x times x prime plus y times y prime, and is 0. So x times x prime plus y times y prime is 0. And now we need, so we have x prime, we have x, we're looking for y prime, so we're going to need y. So when x is 3, what is y? Well, again, we're going to use our relationship given by Pythagorean's theorem. Okay, so I'm going to leave this formula down here so we can use it in a minute. So when x is 3, we have 3 squared plus y squared is 5 squared. And if you solve for y, it kind of looks like a 4. In fact, y does end up being 4. So you solve for y and you get 4. Okay, so here, now what we know is that y is 4 when x is 3. Okay, so we're ready to plug everything in. Remember what this equation is. You need to write it down. I'm going to use it right now. Finally, we get, okay, let me just erase this picture. X times x prime plus y times y prime is 0. And again, we know x is 3. X prime is 3. Let's put in the units up here. Feet, this would be in feet per second. We know when x is 3, we just found out y is 4, and we're looking for y prime. Okay, so now this is the goal. Plug everything in up here. We get 3 times 3 plus 4 times y prime is 0. And so we get y prime is negative 9 over 4. So this is, I'm going to put in the units here now so that we see the answer. This is 9 feet per second, and the negative sign means down the wall. Okay, so again, let me just draw the picture. If this is the wall and this is the ladder, if this bottom of the ladder is moving out, then of course the top of the ladder has to move down, so that accounts for the negative sign. Okay, so 9 over 4 is the answer, and you just saw the solution to problem number 12.